Hi everyone, this is Nicholas JMV. Welcome to video 2 for lesson 3, the tabular division. And these get a little more complicated, so let's go ahead and get started. So I'm going to assume that you know how to set up the table to divide these two. Okay, so we're taking x cubed minus 4x squared plus 7x minus 28 and dividing it by x squared plus 7. So the number of rows is equal to one more than the degree of the denominator. The degree of the denominator is 2. That means we need 3 rows. And the number of columns here is going to equal the power on the top, 3, the highest power, minus the bottom power, and then you're going to add 1. So 3 minus 2 is 1, and then plus 1 is 2. Okay, so we're going to have 2 columns. So this is 3 rows by 2 columns. So let's go ahead and start this out. So 3 rows. Okay, you probably can go like that, and maybe a little bigger. Okay, so 3 rows and 2 columns. Okay, so let's go ahead and we're going to put the x squared now, the x squared plus 7 up top here. Okay, and then what we're going to do is, remember, the first term, the x cubed, is going to go in the first box here. Okay, and the constant minus 28 is going to go down here. Okay, so we could have put the x squared plus 7 over here, but we didn't. I chose to put up here. So we're still finding the quotient here. So let's go ahead and look, and we could say, all right, well, what number times 7 is negative 28? That's negative 4. Okay, and we can multiply here. X squared times negative 4 is negative 4x squareds. Now let's look at the numerator. 3, 2, 1. It doesn't look like it has 3 power, second power, first power, 0 power. So this is going to be some kind of x squared term up here going diagonally. Okay, we need negative 4x squareds. We already have negative 4x squareds, so this one here has to be 0x squareds. Well, the only way that's going to happen is if we have 7 times what gives us 0x squared. It would be an x squared term. Okay, but it doesn't matter because it's 0. So this whole thing, this is just going to be 0. This and this is going to be 0. It doesn't even matter what this is. Okay, so let's keep looking at what we need. Okay, we know here x squared times what gives me x cubed. Okay, so this is just x, right? X squared times x is x cubed. That means this 7 times x gives me 7x. Okay, so we have the x cubed, we have the 7x, we have the minus 4x squared, and we have the minus 28. So look, so don't be surprised. This is a different example now. Look, we have a 0 column, or excuse me, 0 row here, and that can happen. So our quotient is just x minus 4. It's just that simple, x minus 4. Okay, so let's look at one more example. And so let's look at, we're going to find the quotient here. Look how big this numerator is. 3x to the 5th plus 12x to the 4th plus 11x cubed plus 2x squared minus 4x minus 2 all over 3x squared. So the number of rows we're going to need is 3. It's 1 more than the denominator's power. The number of columns that we're going to use is the numerator's power, which is 5, minus the denominator, so 5 minus 2 plus 1, so that's going to be 4. So we have 3 rows by 4 columns. Now watch what happens here. And these are not perfect boxes, and we need how many rows? 3 rows. But if I do my standard 3x squared, I only have 2 spots. So what I'm going to do here is I'm going to skip this spot here in the middle, and I'm going to put the negative 1 down there. And I think about this being some kind of x term, right? 2, 1, 0 power. And the 3x to the 5th is going here. And the negative 2 is going here. So some of these are easier to fill in. So let's go ahead and do that. Negative 1 times 2 is negative 2. So 2 times 3x squared is 6x squared. Okay, And then let's look out what else we have. Do we have anything else we can do? We've got 3x squared to 3x to the fifth is x cubed, and that makes this negative x cubed down here. Now, for argument's sake, what I'm going to do here is something similar. Look how many x squared terms we'd have to have. 1, 2, 3. I'm going to assume that this middle row is going to be 0, okay? And I'm going to go ahead and I'm just going to x these out. I'm going to say that's all zeros. I'm going to take an educated guess, okay? Now, because we go 5, 4, 3, 2, 1, 0, I know that way over here this should be an x squared term. And notice how there's only 2x squareds up here. So I actually have to, if I have 6x squareds, I have to take away 4x squareds here. Okay, and then negative 1 times what gives me negative 4x squareds? Well, that's 4x squareds. Okay, and I can get this box now. 4x squared times 3x squared are 12x to the fourth. Hey, and look at that. Look. We have 3x to the fifth and negative 2 we put in there. There's our 12x to the fourth. We have now our 2x squared, because 6x squared minus 4x. And now we need our cubic. And right now, look, we have a negative cubic and we need 11. So we need 12x cubed here, because 12 minus 1 is 11, and we need 11. So 3x squared times what gives me 12x cubed? It's going to be 4x. And notice the powers go down. 3, 2, 1, 0. Good. And now we have 4x times negative 1, which is negative 4x. And does that meet our criteria? Look, there's negative 4x. So it works out. So look, I had a space here, and I just assumed, and I just counted as 0, and it worked out. So that's going to happen sometimes. There's a couple of these that are tricky where you skip a power, like 2, there's no power here in the middle, and it just goes to the constant term. And when you have those, you're probably going to have a row or a column of zeros. It's just really some trial and error. Okay, so I hope that helps on a couple of examples out of the homework. And if you guys have any questions or comments, please let me know, and we'll see you next time.